Welcome to this installment of forces. In this particular installment, we're looking at forces and inclined planes. There's a series of 5 related lessons on this. And let's first situate ourselves here. Of course, we know that in physics we're dealing with this large field of mechanics that can be broken down into kinematics and dynamics. And the two most important ideas in physics being the conservation of momentum and the conservation of energy. So dynamics is the why of things, which is explained by momentum and energy. And what is helpful at another level of detail to explain momentum and energy, the goings on, are the forces. And we've learned a number of basic forces here. And we're going to take an interlude now to talk about the geometries associated with forces. And the first of those we're going to deal with is the inclined plane. It's a very special case we'll look at. In the other one we will get to in another week or so, and that is when we have forces in circles or circular motion. So we're looking at the inclined plane today, these are geometric cases where we apply forces. So first, the cast of characters of the forces for inclined planes. We have the weight, or the force of gravity. We also have the force normal, or the normal force, which we know means perpendicular to the surface. We have the applied force. And down below we have an inclined plane, and we know that gravity, or the weight, points downward. And we know the normal is perpendicular to the surface. And an applied force could be applied in such a way that it pushes the object up the plane or down the plane. And then we have FG parallel. It is the component of gravity parallel to the inclined plane. What gravity does when we're acting on an inclined plane is it does two things. It pulls the body into the inclined plane. And it also serves to pull it down the plane. And we can see down the plane means it's parallel to the plane. So part of gravity pulls it down the plane or parallel to the plane. The other component is perpendicular to the plane. It is the component of gravity perpendicular to the plane. To which you might be asking yourself, well, doesn't that make it normal? Well, indeed it does, but we already have a force named normal. So we can't have two forces named normal. So what the force of gravity perpendicular is it's that part of gravity that opposes the normal in the opposite direction and it's pulling it into the plane. And I will use this phrase again later, but when we break the force of gravity, the weight, into its components, what we are doing is a coordinate transformation. It's a very fancy word, and we've seen it before. We could look at our XY axes or XZ axes like I've just drawn in blue, or we could look at them as if they are drawn in red like this. We can see that gravity is in this direction, but normal is in this direction. So they both work nicely, but in different coordinates. So what we do is we take the force of gravity and transform it so it's in the same coordinate frame as the inclined plane. So if this is an x-axis, and this is the positive direction, and that's the negative direction. And this is the z-axis, and this is positive, and this is negative. As opposed to positive, positive, negative, negative. And so what we're doing is transforming gravity that's in one coordinate plane to another coordinate system, coordinate transformation. So those are the first 5 characters in this play. Then we have the force of friction, static. Static friction, which we remember is stationary, and dynamic friction, which is sliding friction, where the molecules slide past each other. So this is the cast of characters. We should know all their symbols, and we should think every time we're dealing with an inclined plane, we need our entire cast of characters. We need the entire cast. Now there's another bit of information here that has to do with the angles. This angle down here, the angle of inclination, incline, the angle of the incline theta is the same as this angle here. When we draw the normal force, this normal line that extends through the inclined plane, we have the direction of the normal force going upward. We have the component of gravity pulling it into the plane in the other direction. This angle, subtended by the force of gravity, the weight, and the normal line extended through, that angle theta is the same angle as that theta. Now that is just something for you to know. In the next installment, we're going to prove it. But it's suffice it to say that really all you need to do is know that they're equal to each other. And so that's our first installment on inclined planes. And as I just said, we will, in 4.2, we will have a fun time proving that relationship.